Hey, welcome back to another example using the table method to solve integrals in calculus. So we want to figure out what is the solution to this problem. Like, what is the integral of this whole nasty thing? When I first look at this, I see square roots of x's and multiple things on the top and bottom and some kind of polynomial function, and it really stresses me out. But I also know that generally, if you have multiple terms on top of the fraction in the numerator and one single term in the bottom, then you can split it out into, like, in this case we have 3 terms on top. We can split this out into 3 separate expressions. So let's start with that and see what that kind of does for us. So the integrals is going to be equal to, this is going to be equal to 5x squared over x root x dx. So that's one integral, plus the integral of 4 root x over x root x, plus that is also dx, plus the integral of 12 dx over x root x. And maybe we can make that look a little bit more clean. So already this is starting to look more manageable, but we can definitely cross out some things here. So we have x squared over x. Let's for sure cross that out. And now we still have x over root x. So that's the same thing as 5x over root x. That's the same as 5x times x to the negative 1/2. And that's basically x to the power of 1 times x to the negative 1/2. This is equal to 5x to the 1/2. You just add those exponents, which is also equal to 5 root x, however you want to write it. I'm going to go with this form because I think it will be easiest for the operations that are coming. So this is equal to the integral of 5x to the 1/2, and actually this is a constant, so we can bring the constant right outside of the integral sign always. So we have 5 times the integral of x to the 1/2. Maybe let's even bring that in a little bit closer, just like that, dx. Okay, plus we're going to bring out that constant as well, 4 times the integral of, let's cancel stuff out, we have x root x like that. So we're just left with 1 over x dx. And then the last one, we can bring out that 12, which is a constant, times the integral. This is basically 1 over x root x, but again, I'm going to write this in a form so that it has an exponent. So this is basically the same as 1 over x times x and a half, which is equal to 1 over x to the 3/2 through exponent rules when you just add the exponents. And when we have an exponent in the bottom, we can bring that up to the top. So we have x over negative 3/2 on the top over 1. So let's write it like that. So at this point, if you know how to solve these already, then go for it. But if you don't know how to solve them right now, that's no problem. This is where we're going to use the table. So we're going to open up our table or formula sheet, which is right here. And this is a link on the Engineer for Free website. So you can go, I'll put a link actually in the description below where you can click and just open this right up on your computer. Or there's also a PDF version where you can download it and print it off if you want. But this is pretty typical of what you would get in like a formula sheet for an exam, stuff like that. So we're looking here at the integral of x to the n dx and the integral of 1 over x dx table entries. So let's just copy these over onto our worksheet so we can see. So that was the integral of x to the n dx. This is equal to x to the n plus 1 over n plus 1. And then also the integral of 1 over x on that table was dx, is just equal to ln of x plus c, and this one was also plus c, the arbitrary constant. So when we look here, this one has the form of the integral of x to the power of n dx. So we'll be able to swap this out with n just being, in this case, 1/2. This guy here is the integral of 1 over x dx, so it has this form, so it's just going to turn out to be ln of x. And this one has the form also of x to the n, and in this case n is going to be negative 3/2, and so we're just going to take that into consideration in this term. So let's go through one at a time. We'll solve the first term first. So this is going to be 5 times x to the 1/2 plus 1 is x to the 3/2, and this is going to be over 1/2 plus 1, which is over 3/2. The next term is going to be 4 times this substitution, because we have the integral of 1 over dx, we have the integral of 1 over dx, so we can just substitute this whole thing. So this will be 4 times the ln of x. Technically, these each actually have a plus c as well, and I'll just write them now, and you'll see in a second that they're just going to go away. So that was plus 4 times ln of x plus c plus 12 times x. So in this case, n is negative 3/2 plus 1 is going to be negative 1/2 for that exponent. Negative 1/2. And this will be over negative 1/2 because we're over n plus 1. And in this case, n is negative 3 over 2. And this one is also plus c. But first, talking about these arbitrary constants, this arbitrary constant and this one are all just arbitrary unknown constants, and 3 unknown numbers added together is just another unknown number. So we can just lump them all into one, which you'll see in the next step. We'll just end up with one single unknown constant. And when we divide by fractions, it's the same as multiplying by their inverses here, so we can do that. So 5 times 2, that's just going to be 10 over 3 times x to the 3/2 plus 4 ln of x. And this will be minus 24 x to the negative 1/2, and then plus one single arbitrary constant. And that is our actual solution for what is the integral of that initial expression that we were looking at up at the top. There is another way to write this. Like if you go on Wolfram and you type this in, you're going to see a slightly different form, but you can just rearrange this through like several steps to get there if you want. But I think honestly this is good enough. If you did this, it would show your professor that, hey, at least you know that these, how to simplify this a little bit and how to look up the table and find, the appropriate table entries and, substitute in their solutions, and then come up with something, and lump all of the arbitrary constants into one. I think you'd be looking at, full marks for that at any school, basically, that's testing you on your knowledge of using the table method.